Hey everyone, welcome to the first video of the last chapter of the year, 10.1, talking about stem and leaf plots. Alright, so what is a stem and leaf plot? Well, really simply, it just uses the digits of data. Digits, okay, so we got to think about what digits are. So in 473, there's 3 digits here. Right, the ones, the tens, the hundreds. Okay, it uses the digits of the data to organize the data set. Okay, it takes all these values and uses their digits to organize it. Okay, and we break it up. A stem and leaf plot is broken up into stems and leaves. Okay, and then there's always a key here, and the key explains what the stems and leaf represent. So it says when we have 6, then there's this line and 3. This line that's right there is representing that line right there. So there's a 6 on the left and a 3 on the right. So that's actually talking about that value there. That 6 and that 3 actually means 63, in this case years old, for whatever this was for. Okay, so 4 comma 8 would actually equal 48 years old. So that's kind of what a stem and leaf plot looks like. Let's go ahead and make our own. Alright, so we're going to make a stem and leaf plot of our own here. And what I did is I gave you a table. This is cardio workout time, so the date where the workout was done on and the length of that workout. And we're going to use this little stem and this leaf to help us get started. So you might be thinking, stem and leaf plot, okay, I don't know how to do this yet. That's fine. Let's look back at this picture real quick. I would say at the very least we can organize things by stem and leaf. So we kind of start like a table with 2 columns here. So let's kind of do that. And we'll just use these pictures here to help us. Stem and leaf. Okay, look. Easy as that. You're getting that written down right now, and you're already started. Okay. So we need to now look at our table, though, and think about, okay, what's the smallest value I have to have in my stem and leaf, and what's the biggest? Okay. So the smallest is 5. Okay. And the biggest, though, I got to go is 65. So my table needs to represent that. So anytime you've got a single digit number, okay, such as 5, but then you're going to have to combine double digits, what I like to do is this. My stem is going to be 0, and my leaf is 5. Okay, so the stem 0, 0, 5. So, but I'm trying to represent 5. So what does that mean the stem is? Well, let's maybe do the key first. When we did 0 on that side and 5 on that side, we intended that to represent the number 5. So I'm going to draw the key, and we're going to say 0, 5 is 5. So it seems like the stem was in the tens place, right? But the leaf was in the ones. Okay, so 0, 5 is the number 5. Okay, so how would we do 15 then? Well, if the stem represents the tens place in 15, what's in the tens place? The 1. Okay, and then what's in the leaf place or the ones place? The 5. Okay, if 0 line 5 means 5, then 1 line 5 means 15, and that's good. Okay, so let's keep on going. 25 would be next, so our stem is 2, our leaf is 5. Then we got another 25. So how do we do that? This is when we're going to use the same stem, but we do have to add another leaf. Okay, so we're still going to use the stem of 2, but now let's add a leaf of another 5. Okay, so we've done 1, 2, 3, 4. Now we're on to 35. New stem, new leaf. Now 40. So the 4 is in the tens place. The 0 is in the ones place. 50. Okay, there's a little more room. And then finally 65. Okay, so again, stem, line, leaf, 0, line 5 is 5, so 4 line 0 is 40, which is good because we have a 40 from up there. Okay, so hopefully that's making sense. We'll do a few more of these so you can get some practice. Alright, so for this next one, let's say there was a strawberry eating contest, okay, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9 competitors, and these are the varying amounts of strawberries they ate. We'll say it's in LBS or pounds. Okay, so let's make a stem and leaf plot so we can kind of organize our data by the digits. So again, you need to start out with a stem column and a leaf column. Stylus is not working like it used to. Oh my goodness. L, E, A, F. There we go. Okay. Stem and leaf. So we got to go as low as 6. We got to go as high as 56. Okay, so remember when we have single digits or data that is only in the ones place, we're going to start with 0 as our stem. So we're going to have 0 and 6. And again, what are we trying to represent there? The number 6. So let's go ahead and do our key. I'm going to give myself a little more room. Probably need to come down a little further. Our key, okay, we're going to say 0, line 6 is actually representing the number 6. So for 8, we already have a stem of 0 in the tens place. So now we're going to do an 8. And now to 12. Okay, awesome. New stem, right, at 1 and 2. If 0, line 6 is 6, then 1, line 2 represents 12. And then we got 18. Same stem as up here with 12. Okay, and then we got 22, so 2 and 2. Now we got another 7. Okay, so this is why pencil is important, because not another 7, but we have a 7, and he's going to kind of go along with these guys up in this row. So we're going to I'm going to squeeze him in there because it doesn't let me erase back any further than that. Kind of wedge him in there. Okay, but on yours, you can erase, make some room. And then we got 45. Okay, so, okay. 45, but from 2 to there's nothing that starts with a 3. Okay, so in stem and leaf plots, it's kind of like dot plots. Okay, remember in dot plots we want to identify gaps. So same thing in stem and leaf. There's no data up here that starts with a 3. Nothing in the 30s, right? But I still need to give myself a stem for that. Okay, now we don't fill it in because there's nothing to go along with it. But now we can move on to the 4. We got 45. And then next stem is going to be 5. We got 52 and a 56. So 5, 2, keep the same 5 and go with 6. All right, there we go. That is the stem and leaf plot for pounds of strawberries eaten. All right, so next we're going to practice interpreting a stem and leaf plot. Okay, so we're going to look at a stem and leaf plot that's already created and figure out how it's helpful. Okay, so let's take this one right here. All right, guys, pull this one out of your book because it's pretty good. If they give you test scores, okay, for maybe it's for a class, okay, stem and leaves, and they say key is 9, line 2 is 92, okay, so if 9, line 2, which we're going to find right there is 92, then 6, line 6 would be 66%, 10, line 0 would be 100%, okay, so maybe what you're noticing is that in all of our stem and leaf plots thus far, the leaves are all single digits, but now we're going to start having stems that go into more than one digit. That's okay, but as long as it matches up with your key. So how many students scored less than 80%? Well, each leaf represents an individual student. So how many people scored less than 80%? Well, we have 1, 2, 3, 4 leaves there and 1 there. So we got 5 students. Okay, scored less than 80%. Pretty easy, right? All right, how about this one? What percent of students scored a 90% or above? Okay, what percent, so we've done percents before, right? Scored a 90% or above. Well, how many scored a 90% or above out of how many people total took it? Well, we have 1, 2, 3, 4 people who scored a 90 or above out of how many total people? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 4 out of 18. But remember, percent means per 100. So this is a 4 per 18. I need it to be something per 100. Okay, so how do I get an 18 to be 100? Ooh, man, I don't know about that one. That one's kind of tough. I don't know. I could reduce, to 2 nines, but still. So remember, these tough ones we can cross multiply. And this question mark really we could say represents a variable x. So 4 times 100 is 400 equals 18 times x is 18x. And you guys know how to solve this. All you have to do is get rid of the multiply by 18 by dividing by 18 on both sides. And when you go ahead and set that up and do that, I'll save you a little bit of time right now and give you the answer. It's 22.2 repeating is equal to x, okay? And we were indeed solving for our percent there, okay? Because remember, part over base equals percent over 100, so that's how we set that up. So we were solving for a percent, so that is actually our answer. 22.2 repeating percent of the students in that class scored a 90% or above. All right, lastly, let's just generally talk about the distribution of the data. So let's look at the stem and leaf plot, and let's talk about the distribution. What do we see here? One person got a 66, someone else got 100. Got some low 90s to higher 90s. We've got some low 70s to high 70s, but a lot right here in the middle. Okay, so what I would say is that there's very few low scores and there's very few high scores. Most of our data or our scores are kind of right here in the middle, concentrated in the 80s. Okay, so you can describe that in a number of ways, but that's just kind of what we're seeing. And the stem and leaf plot helps us to visually kind of see that sort of as a curve. Alright, so now what we're going to do is we're going to use a stem and leaf plot to find the measures of center. Okay, so we've given a stem and leaf plot, and then we can extrapolate some of these things from chapter 9 out of a stem and leaf plot. So if we look down here, we're going to find the measures of center, namely the mean, the median, the range, the first quartile, third quartile, and interquartile range, using the stem and leaf plot. And so I'll get us started on the mean. So mean, again, just means average, right? So you add them all up and divide by the number of things you added, right? So let's look here. We've got, we've got to draw the key. My bad, key. What in the world are those things? Mean, okay, so I'll say 2. You don't have to start with the first one, so I'm going to say 2 line 2 equals the number 22. Okay, so as I'm pulling values out, I've got a 10 and a 13. Next, I've got a 20, a 22, and a 24. Then I've got 25, 27, 29. Running out of room here. And then lastly, I've got this 64, and so we'll just keep them. Okay, we're not going to worry about outliers right now. And we're going to, of course, divide all of that by the number of pieces of data. So if you do a count, you see there are 9 pieces of data. Okay, so what does all of that add up to? Save you a bit of time and tell you it's 234 divided by 9. Okay, so when you take 234 and divide it by 9, you end up getting a nice round number, actually, of 26. Okay, so that would be our mean, 26. We pulled that out of the stem and leaf plot. Now you might be asking, why didn't you use 30 and 40 and 50? Well, look, 3 is not paired with a 0 or anything else. Neither is 4 or 5. That's not a 30, it's not a 40, it's not a 50. Those guys are, remember, just place holders. Okay, and what I think I'll do is I'm going to leave the rest of this up to you guys to finish. You've done all of this. Of course, you know median, range is just biggest minus smallest, first quartile, third quartile, and interquartile range. We did all of that just very recently, so I'll leave you to it. Thanks, guys, for sticking with it. I'll see you in class.